Hello, dear friend. It is a pleasure to have you here in this quiet space of wonder. Before we begin our journey through the stars, I invite you to settle into your most comfortable position, letting the weight of the day melt away into the softness of your surroundings. If you enjoy these peaceful explorations of the deep cosmos, please consider liking this video and subscribing to our channel so we can continue to travel together through the silent reaches of space. I would also love to hear from you. Please share in the comments which city or country you are joining us from tonight as you prepare for rest. Now, let your breath slow down as we turn our gaze away from the familiar world and toward the infinite reaches of the night sky, where the very structure of existence begins to reveal itself in the form of the galaxy. Long before we understood the true scale of the heavens, early observers looked upward and saw a faint, milky band stretching across the darkness. They called it the Via Lactea, a path of light that seemed almost ethereal. It was not until the 18th century that thinkers like Immanuel Kant proposed these might be island universes, vast systems existing far beyond our own. This realization shifted our perspective from a lonely solar system to a participant in a much larger narrative, seeing that these were not merely clouds of gas, but complex, structured communities of matter and energy. A galaxy is far more than a simple collection of stars. It is a dynamic, evolving entity, a gravitationally bound system that acts as the primary building block of the entire cosmos. Within its embrace, billions of stars, interstellar gas, and vast clouds of cosmic dust are held together by the invisible hand of gravity. This gravitational bond is a delicate balance, an intricate dance where the kinetic energy of moving stars prevents the entire structure from collapsing inward, while the sheer mass of the system keeps its components from drifting away into the void. Much of this mass is hidden from our eyes, existing as dark matter that forms a silent scaffolding around which the visible light of the galaxy is draped. These systems are never static. They are in a constant state of flux, recycling material and birthing new suns as they drift through the expanding universe. Imagine, if you will, a great ancient forest where the trees are not trees, but suns. Just as a forest is more than just a group of individual plants, a galaxy is a living ecosystem of light. It breathes as gas collapses to form stars, and it exhales as dying stars return their heavy elements back to the interstellar medium. Think of the galaxy as a slow-moving celestial whirlpool, a gentle tide that pulls everything into a cohesive, swirling rhythm. It is a grand, luminous tapestry being woven on a loom of gravity, where every thread is a solar system, and every knot is a cluster of stars. This vast, rotating garden of light provides the stable environment necessary for the complex chemistry of life to eventually emerge, leading us toward the miraculous process of cosmic elemental synthesis. Drifting deeper into the heart of this luminous garden, we find that the galaxy is far more than a mere collection of lights. It is a master alchemist working across eons of silence to refine the very substance of reality. In the earliest moments of time, the universe was a vast, cooling mist composed almost entirely of the two simplest elements, hydrogen and helium. This primordial breath was the raw material of creation, yet it lacked the complexity to build worlds of rock or bodies of flesh. For billions of years, the cosmos waited in a state of elegant simplicity, a blank canvas of gas drifting through the void. It was within the pressurized chambers of the first stars that the true transformation began. Gravity, acting as a patient sculptor, gathered these light gases into dense, glowing spheres, igniting the first fires of stellar nucleosynthesis. Inside these suns, the intense heat and crushing weight forced atoms together, fusing the simple into the complex. This is the cosmic forge, a place where the basic units of existence are hammered into new forms. Carbon, the foundation of all known life, was born in the slow-burning embers of aging stars, while the neon and magnesium that color our understanding of the chemical world were layered deep within their shells. Oxygen, the breath of every living creature, and iron, the strength in our blood and the core of our planet, were forged in the final, dramatic exhales of dying giants. Every atom of gold in a wedding band or calcium in a bone has passed through the furnace of a star, a celestial heirloom passed down through generations of light. When these stars reach the end of their long journeys, they do not simply vanish. They cast their enriched ashes back into the interstellar clouds, seeding the galaxy with the ingredients for future worlds. This process is a form of stellar respiration, an exhale that breathes life into the cold vacuum. The galaxy acts as a giant circulatory system, recycling the ghosts of old suns to create the vibrant diversity we see today. Are, in the most literal sense, the children of this chemical evolution, walking remnants of a stellar legacy that began when the first stars pierced the darkness. As we float through this realization, we see that every star is a vessel of potential, a quiet guardian of the elements that will one day form the mountains, the oceans, and the very eyes that look up at the night sky. The interstellar medium, once a desert of simple gas, becomes a fertile soil enriched by the heavy metals of 1,000 suns. This profound transformation ensures that the universe grows richer and more complex with every passing billion years, weaving the simple threads of the Big Bang into the intricate tapestry of a habitable world, preparing the stage for the grand architecture that defines the cosmic structure. Letting this knowledge settle into the quiet of your mind, we observe how these vast collections of light serve as more than just homes for stars. They are the fundamental markers of the universe's expansion. In the early decades of our understanding, these distant systems revealed a startling truth. The universe is not a static stage, but a growing, breathing entity. As galaxies drift apart, they act as cosmic milestones, measuring the invisible stretching of spacetime itself. This movement is not random. It is the grand progression of a universe that began in a single moment of infinite density and has been unfolding ever since. Each galaxy is a witness to this journey, a point of reference in an ocean that is constantly widening. Beyond their role as markers, galaxies occupy a vital position as the primary nodes of the cosmic web. Imagine a vast, invisible lattice of dark matter stretching across the billions of light years, a skeletal structure that holds the universe together. Galaxies are the luminous blossoms caught in this invisible, stretching net, congregating at the intersections where the filaments of the web meet. These nodes are the junctions where the great rivers of primordial gas and dark matter converge, feeding the growth of everything we see. Within these galactic hubs, a magnificent battle of physics unfolds every second. It is a battleground between the relentless, inward pull of gravity and the explosive energy released by the deaths of massive stars. When a star reaches the end of its life, it does not simply vanish. It erupts with the power of billions of suns, sending shockwaves through the surrounding gas. This feedback provides a necessary counterpressure to gravity's desire for total collapse. If gravity were the only ruler, every galaxy would shrink into a silent, dark singularity. But the violent, beautiful energy of stellar death provides the breath of life that keeps the galaxy puffed out and vibrant. This equilibrium creates the stable environments where planets can form and life can eventually find a foothold. They are the glowing buoys in a dark, rising tide, revealing the depth and the velocity of the cosmic flow. As we contemplate this, we see that galaxies are the anchors of the cosmic web, the places where the abstract laws of physics become the concrete reality of light and heat. They are the balancing points between the stillness of the void and the fury of creation, ensuring that the universe remains a structured, organized masterpiece rather than a chaotic soup of particles. In this grand architecture, every galaxy plays its part, maintaining the delicate poise required for the cosmic story to continue its slow and steady march toward the future. Letting this knowledge settle, we begin to perceive the immense variety in the stature of these celestial bodies, realizing that the term galaxy encompasses an almost incomprehensible range of physical dimensions. Long before we had the tools to measure the distances to the stars, the true magnitude of the universe remained a mystery, hidden behind the faint smudges of light in the night sky. It was only through the careful observation of variable stars that we unlocked the gates to the extragalactic realm, discovering that these systems are not uniform in their construction. On the smallest end of the spectrum, we find the dwarf galaxies, modest and quiet collections of stars that might contain only 10 million suns. These diminutive systems span a few thousand light years across, appearing as subtle glimmers against the backdrop of the void. Yet, as we move through the cosmic catalog, the scale expands exponentially, leading us toward the true titans of the deep. Giant elliptical galaxies represent the pinnacle of stellar concentration, massive conglomerates that can house upwards of 100 trillion stars. These monsters of light stretch across hundreds of thousands of light years, their gravitational influence reaching out like a silent command across the intergalactic medium. The sheer disparity in size is a testament to the diverse paths of cosmic evolution, where some systems remain small and secluded, while others grow through the relentless accumulation of their neighbors. Imagine these structures as a vast collection of oceanic life, ranging from the tiny, translucent organisms that drift with the current to the massive, ancient leviathans that dominate the depths. Each dwarf system is a delicate droplet of light, a fragile assembly of matter that persists in the shadows of larger giants. In contrast, the elliptical behemoths are the mountain peaks of the cosmos, towering over the landscape of spacetime with a presence that bends the very fabric of reality. They are the grand cathedrals of the heavens, built over billions of years through the merging of countless smaller structures. As we float through this sea of varying scales, we see that the universe does not favor a single mold. It revels in the contrast between the minuscule and the monumental. The light we receive from a distant dwarf is a soft whisper, while the radiance of a giant elliptical is a thunderous chorus. Yet both are essential notes in the grand symphony of existence. This hierarchy of size reflects the chaotic history of collisions and growth that has shaped the universe since the dawn of time. Every star, whether part of a tiny cluster or a massive empire of light, contributes to the overall density of the cosmic web. We are witnessing the result of a long, patient process of gathering and grouping, where the small find sanctuary in numbers and the large provide the framework for the evolution of the cosmos itself. The scale of these systems is not just a measure of size, but a record of their life stories, written in the density of their cores and the span of their outer halos. As our perspective shifts from the humble to the gargantuan, we realize that size in the universe is a reflection of time and gravity working in tandem, molding the chaotic energy of the early universe into distinct, structured realms that range from the flickering candle to the blazing bonfire. Letting this knowledge settle into the quiet corners of the mind, we turn our gaze inward to our own celestial home, the Milky Way. For ages, humanity looked upon the silver streak in the night sky with a sense of wonder that outpaced our understanding. We saw a river, a pathway, or a spill of milk, never imagining that we were peering into the edge of a spinning city of suns of unimaginable complexity. This grand structure is a staggering census of existence, a place where the numbers defy the limits of human imagination. Within the soft glow of these spiral arms, there are between 100 and 400 billion stars, each a unique furnace of fusion, each a potential anchor for a family of planets. To truly grasp the magnitude of this population, one must consider the passage of time. If you were to sit in the stillness of the night and count each star, one by one, clicking them off at the steady rhythm of a single second, the task would consume your entire existence. You would count through your youth, through your twilight years, and as you passed the torch, the count would continue through the lives of your children and their children. It would take thousands of lifetimes, a lineage of observers spanning across millennia, just to acknowledge every individual sun in our local neighborhood. This immense population is often hidden from our view by thick curtains of interstellar dust and the brilliant glare of the galactic core, making the exact tally a mystery that keeps the cosmos humble. Many of these stars are the small, enduring red dwarfs, the quiet laborers of the galaxy that burn with a steady, low flame for trillions of years, outlasting their more flamboyant siblings. Our galaxy is like a vast, ancient desert where every grain of sand is a burning sun, stretching beyond the horizon in every direction. It is an infinite meadow of fireflies, where each flickering light represents a history, a chemistry, and a destiny that we are only beginning to decode. This census of light includes stars of every conceivable variety, from the massive blue giants that burn hot and fast to the tiny, cool dwarfs that endure through the eons. Each one contributes to the collective glow that we see from our vantage point on a small blue world. When we look at the Milky Way, we are looking at the combined radiance of 100 billion stories, a collective memory etched in photons that have traveled for thousands of years to reach our eyes. It is a dense, eternal mist where every droplet is a sun, refracting the light of its neighbors into a soft, cohesive haze. We are part of a massive, glowing congregation, a single note in a symphony that has been playing since the dawn of time. The Milky Way is a grand library of light, where every star is a volume waiting to be read, and every planet is a footnote in the story of the universe. We are nestled within this silver metropolis, a quiet suburb in a city that never sleeps, surrounded by a billion possibilities that shimmer just out of reach in the velvet dark. Drifting deeper into the expanse, we begin to realize that our own galaxy is but a single grain of sand on an infinite shore. For centuries, we believed the Milky Way was the entirety of the cosmos, a solitary island in a void of nothingness. It was only when our mechanical eyes peered into the deepest shadows that we discovered the true scale of the population of existence. There are an estimated 2 trillion galaxies scattered across the observable horizon, a number so vast it defies the grasp of the human mind. Each of these structures is a self-contained world, a massive assembly of billions of stars, gas, and dust, all orbiting a common center of mass. At the heart of nearly every one of these galactic giants lies a supermassive black hole, a gravitational keystone of such immense density that it bends the very fabric of space around it. These central engines act as the silent conductors of a galactic orchestra, regulating the flow of matter and the birth of stars within their domains. Yet, even these visible behemoths are encased within something far more profound. Every galaxy is cradled by a dark matter halo, an invisible cocoon of mass that provides the necessary gravity to keep the stars from flying apart into the void. This unseen substance outweighs the visible matter 5 times over, acting as the structural foundation upon which all light is built. Imagine the universe as a luminous caravan crossing a desert of night, where each galaxy is a distinct traveler moving through the vast, silent dunes. From our vantage point, these travelers appear isolated, yet they are part of a grand, interconnected network of existence. Each galaxy is like a bioluminescent bloom in a dark, oceanic trench, pulsing with the rhythmic movement of its internal components. The supermassive black hole at the center is the deep-sea vent, a source of incredible energy and influence that dictates the life cycle of the surrounding ecosystem. The dark matter halo is the invisible current that holds the entire structure together, a silent pressure that ensures the integrity of the galactic form. We are observing a cosmic blizzard where every snowflake is a galaxy, each containing its own unique history and trillions of individual stories. This staggering density of existence suggests a universe that is teeming with activity, a crowded theater of creation where every seat is filled with the potential for life and wonder. As we gaze out at this vast population, we see a mosaic not of tiles, but of entire worlds, each one a testament to the enduring power of gravity and the persistent radiance of matter. The composition of the cosmos is a delicate balance between the seen and the unseen, a harmony of light and shadow that allows the universe to flourish in its magnificent complexity. Drifting deeper into the layers of the celestial past, we find ourselves assuming the role of cosmic archaeologists, sifting through the luminous dust of antiquity. This pursuit, known as galactic archaeology, allows us to treat the vast expanse of space as a grand, living museum where the exhibits are not static, but are currently unfolding their ancient stories across the reaches of space. To look out into the dark is to look back into the depths of history, for the light we perceive is a traveler that has crossed unimaginable distances to deliver its message. When our telescopes capture the faint glow of a galaxy positioned 1 billion light years away, we are granted a vision of that system as it flourished 1 billion years in the past. We are observing the universe in a state of perpetual retrospection, where the speed of light acts as a cosmic archivist, meticulously filing away every moment of stellar birth and galactic collision. This fundamental principle of astronomy transforms the sky into a series of geological strata, where each increment of distance represents a deeper layer of the past. The study of galactic astronomy is, at its core, a study of the history of matter itself, a search for the origins of every atom that now resides within our own bodies. By analyzing the chemical compositions and orbital paths of these distant suns, we can piece together the sequence of events that led to the current architecture of the heavens. It is a process of uncovering the visual fossils of the cosmos, finding the remnants of early mergers, and the traces of primordial gas clouds that have long since been consumed by the furnace of star formation. Imagine the universe as a vast, multidimensional time-lapse photograph where every pixel represents a different era of creation. We are leafing through a celestial scrapbook where the pages are made of starlight, and the ink is the very energy of the dawn of time, still cooling as it stretches across the void. The cosmos does not hide its history. It broadcasts it continuously, etching its biography into the very fabric of the vacuum. We are like scholars deciphering the ancient scripts written in the language of gravity and light, realizing that the distant flickers we see are the echoes of a younger, more turbulent world. This stratigraphic view of the heavens allows us to witness the slow, patient assembly of the cosmos, seeing the progression from chaotic clusters of gas to the elegant, ordered majesty of the modern spiral. In this quiet observation, we realize that we are part of a continuous lineage of matter, a sequence of transformation that spans the entirety of time, preserved forever in the archival vaults of the deep night. Letting this knowledge settle within the quiet expanse of the mind, we begin to understand that the universe does not reveal its story in a single, linear narrative, but rather through a vast collection of snapshots scattered across the light years. To look out into the deep field of space is to look back into the depths of time, utilizing the finite speed of light as a natural chronometer. In the furthest reaches, where the light is stretched and reddened by the expansion of the void, we find the ancient proto-galaxies. These are not the elegant, symmetrical structures we see nearby. They are small, chaotic, and clumpy, resembling fragments of a broken mirror, rather than a finished work of art. These early assemblies were the sites of intense, rapid star formation, fueled by the cold streams of primordial gas falling into the dark matter halos. Through the lens of our most powerful observatories, we see these turbulent ancestors as they were billions of years ago, engaged in a violent yet creative struggle to find stability. As we move our focus closer to the modern era, we witness the gradual maturation of these systems. We see the hierarchical merging of smaller units into larger ones, a process where gravity acts as a patient weaver, blending disparate clouds of gas and stars into the first coherent disks. The chaotic motions of the early stars eventually give way to the organized, circular orbits of the galactic plane. This is the reconstruction of cosmic history, a painstaking assembly of disparate moments into a single, continuous biography of the heavens. We see the transition from the adolescent turbulence of the deep past to the serene, middle-aged stability of the grand design spirals. Each galaxy we observe at a different distance represents a different chapter in this autobiography, allowing us to bridge the gap between the formless glow of the afterglow and the intricate, rotating cities of stars that define our current perspective. It is a slow-motion metamorphosis, an unfolding origami of matter that has taken 13 billion years to reach its current state of complexity. By mapping these changes, we are essentially building a time-lapse photograph of existence itself, recognizing that the stillness we perceive tonight is merely a brief pause in a much longer, more profound journey of transformation. We are the inheritors of this long sequence, the observers who have finally learned to read the tattered, scattered film reel of the stars, finding the patterns of growth that connect the smallest spark of a proto-galaxy to the vast, luminous majesty of the spiral arms. Letting this knowledge settle into the quiet corners of the mind, we find ourselves standing at a pivotal threshold in the human story, a moment where the scale of reality was poised to expand beyond all previous imagination. In the spring of 1920, within the marble-hushed halls of the Smithsonian Museum of Natural History, two men stood before an audience to argue the very dimensions of the heavens. This was the Great Debate, a formal confrontation that sought to resolve a fundamental mystery. Were the spiral nebulae we observed through our telescopes merely small, swirling clouds of gas tucked within the edges of our own Milky Way? Or were they something much more profound? The atmosphere was thick with the weight of centuries of astronomical tradition, yet it hummed with the electric tension of a new era. At the heart of this intellectual tug-of-war was the question of distance and the true nature of the spiral structure. Harlow Shapley argued for a single, vast Milky Way, a monolithic stellar province so large that everything we could see was contained within its borders. He viewed the spiral nebulae as nearby gas clouds, perhaps the birthplaces of stars, trapped within the gravitational embrace of our home galaxy. Heber Curtis, on the other hand, proposed a radical alternative, suggesting that these spirals were detached stellar realms in their own right, distant and independent world systems comparable to our own, separated by unimaginable gulfs of empty space. This debate was not merely a disagreement over numbers. It was a struggle to define the boundaries of the known world, using the faint, spectroscopic signatures of light to measure the unmeasurable. They analyzed the velocities of these nebulae and the brightness of novae within them, searching for clues in the dim, fuzzy patches of light that defied clear categorization. Imagine for a moment that we are standing on a fog-shrouded misty coast at midnight, staring out at a series of distant, shimmering lanterns. To one observer, these lights are small candles held by people walking just a few yards away in the mist, their glow softened and spread by the damp air. To another observer, these same lights are the blazing beacons of massive lighthouses situated on entirely different continents, appearing small only because they are thousands of miles across a dark and heaving ocean. This was the essence of the 1920 debate, a choice between a cozy, singular harbor and a vast archipelago of light scattered across a sea of infinite depth. It was a moment where the human ego had to decide if it was the center of a solitary landmass or just one inhabitant of a sprawling nautical world of hidden continents. The Smithsonian became a sanctuary for this inquiry, a place where the logic of light met the limits of human perception, preparing us to accept that our home was not the entirety of the cosmos, but rather a single, quiet room in an endless mansion of stars, a celestial inkblot that held the secrets of a much larger, more mysterious geography. Letting this knowledge settle into the quiet corners of the mind, we turn our gaze toward Harlow Shapley, a man who looked upon the night sky and saw a singular, majestic unity. In the hushed atmosphere of the early 20th century, Shapley's hypothesis was a bold assertion of scale, a vision where our Milky Way was not merely a member of a cosmic crowd, but the grand, solitary stage upon which the entire drama of the universe was performed. He argued with the conviction of a cartographer who had discovered his map was far larger than any had dared to dream, suggesting that the spiral nebulae, those ethereal swirls of light, were not distant sisters of our own galaxy, but rather small, local phenomena, perhaps gaseous clouds or minor clusters caught within the gravitational embrace of our own massive system. To Shapley, the universe was not a scattered collection of island realms, but a monolithic province of stars, an all-encompassing structure that stretched beyond the limits of previous human imagination. Technically, his reasoning was anchored in his groundbreaking study of globular clusters, those ancient, tightly packed spheres of stars that orbit the galactic center like loyal sentinels of time. By using these clusters as luminous markers, Shapley realized that the Milky Way was vastly larger than the sun-centered models of his predecessors, spanning what he believed to be 300,000 light-years. This immense scale led him to a logical crossroads. If our galaxy was truly this gargantuan, it seemed improbable that other, similar structures could exist as separate entities. He interpreted the absence of these nebulae from the plane of the galaxy, not as a result of obscuring dust, but as evidence that they were part of a singular, atmospheric envelope surrounding our home. Imagine, if you will, a single ancient tree of impossible proportions, its roots digging deep into the bedrock of the void, and its branches reaching so far that they touch the very edges of the dark. To Shapley, the universe was this lone, colossal oak. The spiral nebulae were not other trees in a distant forest, but merely delicate, luminescent mosses clinging to the underside of its massive limbs, or perhaps small puffs of pollen caught in a momentary breeze between the leaves. It was a vision of a solitary, sovereign kingdom, a monolithic realm where every spark of light we could perceive was a citizen of the same singular empire. This perspective offered a sense of profound enclosure, a feeling that we were part of a vast, interconnected organism of light, where nothing existed beyond the reach of our own galactic hearth. It was a universe that felt like a grand, eternal house, where every window looked out only onto other rooms of the same magnificent dwelling, ensuring that we were never truly alone in the dark, but always within the warm, familiar walls of our own celestial home, a singular sanctuary in the infinite night. Letting this knowledge settle into the quiet corners of the mind, we find ourselves standing before the monumental work of Harlow Shapley, a man who sought to redraw the map of our celestial home. In the hushed observatory of the early 20th century, he turned his attention to the globular clusters, those ancient, densely packed spheres of stars that appear like shimmering ornaments suspended in the void. He viewed these clusters as the architectural ribs of the galaxy, the structural bones that defined the true shape of the Milky Way. By utilizing the rhythmic pulsing of variable stars as a cosmic metronome, Shapley calculated the distances to these stellar hives, mapping their positions across the deep velvet of the sky. He noticed a profound imbalance. These clusters were not scattered randomly, but were huddled together toward the heart of Sagittarius. This revelation pulled the floor from beneath our feet, for it proved that we did not occupy the central throne of the galaxy. Shapley's calculations birthed a model of staggering proportions, envisioning a Milky Way that stretched 300,000 light-years from edge to edge. While he did not yet account for the dimming effect of interstellar dust, that ghostly veil of cosmic soot that masks the true brightness of distant suns, his vision of a vast, decentralized empire was a radical departure from the cozy, sun-centered universe of the past. He relegated our solar system to the quiet suburbs, a humble outpost on the fringes of a grand, rotating metropolis of light. Imagine the galaxy as a majestic, glowing honeycomb of light, where each cell is a star, and the nectar is the very warmth of existence. We are like a single, tiny worker bee resting on the furthest, most delicate edge of this vast structure, peering inward toward a central chamber so brilliant and dense that its glow illuminates the entire cosmos. The globular clusters are like crystalline lanterns hung from the high, invisible rafters of this celestial hive, marking the boundaries of a domain far larger than we ever dared to dream. We reside in a suburban glade of stars, a tranquil neighborhood on the outskirts of a sprawling, luminous estate, where the bustling heart of the galaxy is a distant, golden hearth. This model transformed our world into a grand, rotating carousel of lanterns, where we are merely passengers on a peripheral chariot, swinging through the endless night on the very edge of a magnificent, singular kingdom of light. Drifting deeper into this era of intellectual uncertainty, we find Harlow Shapley standing firm in his conviction that the universe was a singular, cohesive entity. To him, the sheer scale of the Milky Way, which he had so meticulously measured using the heartbeat of the Cepheids, left little room for other giants. If the faint, swirling spirals seen through our telescopes were truly separate systems of stars equivalent to our own, the math suggested a distance so staggering that it seemed to defy the very laws of proportion. He viewed the cosmos not as a collection of scattered islands, but as a monolithic landmass where anything outside its borders was merely a drifting cloud or a minor satellite. This was a battle of scale, a struggle to comprehend just how much empty space the mind could allow before the structure of reality felt too thin, too stretched to be true. The technical core of his resistance lay in the relationship between apparent size and physical reality. Shapley reasoned that if a spiral nebula occupied the same physical volume as our massive Milky Way, its small angular diameter in the sky would place it millions of light years away. At the time, such numbers were considered astronomical heresies, far exceeding the boundaries of what was thought possible for the reach of light. He argued that it was far more logical to assume these spirals were smaller, localized phenomena, perhaps solar systems in the process of formation, or gaseous eddies caught in the gravitational wake of our own galaxy. By keeping these objects close, he maintained a universe that was compact and manageable, avoiding the terrifying implication of a vacuum so vast that it would render our entire stellar empire a mere speck in an infinite abyss. He saw the spirals as nearby whispers of motion rather than distant shouts of existence. Imagine standing on a high, windswept cliff at midnight, looking out over a dark and motionless abyssal plain. In the distance, you see a tiny, glimmering ember, no larger than a spark. To suggest that this spark is a massive lighthouse, identical to the one standing behind you, would mean that the darkness stretches for thousands of miles beyond the horizon, an expanse so wide it swallows the imagination. Shapley chose to believe the light was simply a small lantern carried by a passing boat, bobbing just a short distance from the shore. To him, the spiral nebulae were like delicate feathers caught in a draft just outside a window, rather than great eagles soaring over a land half a world away. He saw the universe as a singular ancestral hall, and the idea of other structures existing across a dark, untraversable moor seemed like a fantasy that threatened to dissolve the comfort of our celestial home. He preferred the intimacy of a solitary watchtower, viewing the swirling mists below as mere clouds clinging to the stone, rather than the peaks of an entire hidden range rising from a valley of eternal shadow. Letting this knowledge settle, we find Shapley seeking a more tangible anchor for his vision, a measurement that would tether these swirling mists to our own galactic shores. He turned to the meticulous work of Adriaan van Manen, an observer whose eyes were attuned to the subtlest shifts in the heavens. Van Manen believed he had witnessed the actual rotation of the spiral nebulae, a slow, majestic winding of their luminous arms over the course of mere decades. To Shapley, this was the definitive proof he required. If these structures were truly island universes, vast and distant beyond comprehension, their apparent rotation would be a physical impossibility. The geometry of the heavens is a rigid master. If a distant object appears to turn even a fraction of a degree in a human lifetime, its outer edges must be racing at speeds that defy the fundamental laws of light and time. If the spiral of Andromeda were as far away as Curtis suggested, its rotation would require its stars to hurtle through the void at velocities exceeding the absolute limit of the universe. It was as if one were watching the slow sweep of a lighthouse beam from across a narrow bay. If that same beam were coming from the far side of the world, its light would have to travel with a fury that would tear the fabric of reality asunder. Shapley saw the nebulae not as distant empires, but as faint ripples in a backyard pool, small enough that their movement could be perceived by a patient watcher on the bank. He viewed them as a child's spinning top, humming within reach, its wobbles visible because it occupied the same room as the observer. To imagine them further away was to imagine the minute hand of a cosmic clock sweeping across the diameter of a continent in a single breath. In his mind, the universe remained a cohesive, singular entity, where the surface of a mill pond was disturbed only by the gentle falling of nearby leaves, rather than the churning of hidden oceans. This evidence felt like a solid stone beneath his feet, a confirmation that the grand architecture he envisioned was the only one that obeyed the logic of the local world. He could not accept a reality where the stars broke the speed of light simply to satisfy a theory of distance. The spirals were, to him, intimate neighbors, their quiet revolutions a testament to a universe that was vast, yet ultimately contained within a single, magnificent boundary, avoiding the chaotic fragmentation of 1,000 separate worlds. Letting this knowledge settle, we find ourselves turning away from the comforting borders of a single, all-encompassing home to look out upon a much colder, much more expansive horizon. While Shapley stood firm on his singular island of light, Heber Curtis gazed into the same darkness and saw something fundamentally different, a vision not of one great empire, but of a decentralized cosmos that refused to be contained. He revived a thought that had long slumbered in the minds of philosophers like Immanuel Kant, the concept that the spirals were not mere clouds within our reach, but distinct, autonomous realms in their own right. To Curtis, these nebulae were not the swirling eddies of a local stream, but were themselves vast, self-contained systems of stars, existing at distances so profound they defied the human instinct for proximity. He looked at the great nebula in Andromeda and did not see a nursery of gas, but a mirror of our own Milky Way, a twin city separated by a gulf of empty space that stretched beyond the reach of any local measurement. This was a radical shift in perspective, moving from a universe with a single heart to one with 1 billion hearts, each beating in its own rhythm across an unfathomable abyss. Curtis argued that if these spirals were within our galaxy, they would be subject to its laws and its distribution. Yet, they seemed to shy away from the galactic plane, hiding behind the dusty veils of the Milky Way's edge like silent travelers avoiding a crowded port. This zone of avoidance was not a sign of their insignificance, but a clue to their independence, suggesting they were external entities viewed through the lens of our own stellar outskirts. He saw the universe as an endless oceanic expanse, where our entire galaxy was but one among many thousands of scattered landmasses, each a sovereign province of light. In his mind, the great spirals were not subordinate features of a singular landscape, but independent vessels sailing through the limitless brine of the void, governed by their own internal gravity and history. This hypothesis transformed the cosmos from a solitary cathedral into a boundless chain of cosmic islands, where every point of light might represent an entire history, an entire architecture of stars, unfolding in total isolation from our own. It was a perspective that demanded a vast increase in the scale of reality, suggesting that the light we see is not just a neighborly glow, but a message from a distant shore, traveling for eons across a vacuum that Shapley could not imagine. There was a majestic freedom in this view, the freedom of a universe that knew no final boundary, an infinite field of fires where each spark was a world unto itself, drifting forever in the grand, silent currents of the deep. Drifting deeper into this ocean of distance, we find Heber Curtis standing at the edge of the known, searching for a signature of scale that could bridge the gap between intuition and proof. His gaze was fixed upon the Andromeda Nebula, a smudge of light that many saw as a mere wisp of local vapor. But Curtis looked closer, seeking the rare and violent flares known as novae, sudden, brilliant outbursts, where a star briefly outshines its neighbors before fading back into the dark. He began to catalog these events within the spiral arms of Andromeda, comparing their intensity to the novae recorded within our own Milky Way. The data revealed a staggering discrepancy. The flashes in Andromeda were not merely dim, they were ghostly, thousands of times fainter than the outbursts seen in our local neighborhood. If a nova was a standard event, a signature of physics that released a predictable amount of energy, then their apparent weakness in Andromeda could only mean one thing. They were occurring at a distance so vast it defied the prevailing maps of the era. This was the technical cornerstone of his argument, a realization that the laws of nature do not change, only our perspective of them. By treating these stellar flares as cosmic beacons of known intensity, Curtis could calculate the depth of the void between us. He realized that for these explosions to appear so minuscule, the nebula itself had to be located millions of light years away, far beyond the boundaries of any single, unified galaxy. It was a leap of logic that required the observer to trust the math over the visual comfort of a small, contained universe. He saw these novae not as unique anomalies, but as the same fundamental fire, just viewed from the opposite side of a terrifyingly wide canyon. Imagine the dying glint of a match struck on a distant mountain peak. From where we stand, the light is a mere speck, a fragile spark that almost vanishes against the overwhelming black. Yet, we know the heat of that flame, the sudden rush of energy required to create it. If it appears as nothing more than a silver needle's point, it is not because the fire is weak, but because the mountain is an unimaginable journey away. These novae were the fireflies across a vast valley, their synchronicity with our local sparks, proving that the valley was wide, and the other side was a world unto itself. They were the soft blink of a distant lighthouse on a separate continent, signaling across a sea of vacuum that no ship had ever crossed. In this view, Andromeda was no longer a cloud in our sky, but a majestic, independent city of light, its windows glowing faintly because of the sheer volume of the night that lay between its streets and our own. Each nova was a message, a small, luminous pulse that confirmed the existence of a reality outside our own. A distant shore where the same laws of physics were performing the same grand dramas on a stage we could barely perceive. Drifting deeper into the structural heart of this celestial mystery, Heber Curtis sought not just the light that defined these nebulae, but the shadows that revealed their true nature. He observed the spiral nebulae that presented themselves edge-on, appearing as thin, glowing spindles of silver suspended in the velvet blackness. In these profiles, he noticed a striking and consistent feature: a dark, opaque band cutting through their luminous centers, a silhouette of missing light that sliced the brilliance in two. This was not a random imperfection, but a deliberate architectural signature. Within our own Milky Way, the sky is split by the Great Rift, a massive, obscuring cloud of interstellar dust that divides the glowing stream of our home galaxy into two parallel branches. Curtis recognized that this was more than a local coincidence. It was a fundamental trait of a galactic body. By aligning the dark rift of our own backyard with the dark dust lanes of these distant spirals, he was effectively identifying a shared genetic code of matter. If these nebulae possessed the same internal anatomy as our own Milky Way, it stood to reason they were not mere clouds of gas drifting within our borders, but identical, sovereign structures viewed across a staggering distance. The composition of this cosmic soot, this carbon-rich veil that blocked the light of billions of stars, suggested a symmetry that transcended local space. It was as if he had found the same architectural skeletal rib in two different bodies, proving they belonged to the same species. Imagine standing in a darkened theater, looking at the profile of a person in the front row, and noting the specific curve of their brow and the bridge of their nose. Then, looking far back into the shadows of the balcony, you see that same profile, tiny and faint, yet possessing the exact same proportions. The dark rift was like a signature birthmark, or a specific grain in the wood of the cosmos, appearing both in our hands and on the far side of the dark. It was the ink-stained fingerprint of a galaxy, a structural echo that whispered of a universe built from the same blueprint. These dark lanes were the veins in a celestial leaf, carrying the same heavy elements and the same history of stellar death and rebirth as our own. In this realization, the nebulae were no longer mysterious stains on the glass of our telescopes. They were our mirrors, reflecting the same grand design across an ocean of night that was far deeper than anyone had dared to imagine. Drifting deeper into the quiet aftermath of that night in Washington, we find that the great debate did not end with a sudden flash of absolute certainty, but rather with a shared realization that the truth was a two-colored yarn of a single braid. Neither Harlow Shapley nor Heber Curtis walked away with a complete map of the heavens, for the universe is far too vast to be captured by a single perspective. Instead, their intellectual collision left behind a shattered prism of truth, each man holding a vital piece of a puzzle they could not yet see in its entirety. Shapley had been the one to correctly sense the true scale of our own home, pushing the boundaries of the Milky Way far beyond the modest limits of earlier models. He understood that we were not the focal point of the cosmic stage, but residents of a peripheral township of a luminous municipality, displaced from the center by his observations of the globular clusters. Yet, even as he expanded our internal horizons, he remained blind to the external ones, tethered to the idea that everything we could see was contained within a single, sovereign system. Letting this knowledge settle, we see that Curtis possessed the opposite clarity. He was the one who looked at the faint spirals and correctly identified them as independent realms, distant sisters to our own galaxy, forming a sovereign chain of cosmic redoubts separated by a gulf of space that defied contemporary measurement. He saw the true nature of the nebulae as autonomous dynasties of light, yet he clung to an undersized vision of the Milky Way itself, believing our local system to be much smaller and more contained than it truly was. It was a strange symmetry of insight and error, like two overlapping silhouettes of a hidden peak. One man saw the true majesty of the vineyard, but thought it was the only vineyard in existence. The other recognized that there were many vineyards scattered across the world, but misjudged the immense length of the vines surrounding him. The resolution was not a victory for one side, but a binary star of human thought, where two opposing ideas orbited a truth that lay somewhere in between. They were like two navigators on a fog-bound pier, one accurately measuring the depth of the harbor, while the other correctly identified the distant lights of a foreign shore. Neither could see the whole horizon, but together they had framed the question that would define the next century of exploration. The debate proved that the cosmos was not a simple structure, but a complex hierarchy of scales. It taught us that the human mind often struggles to hold two vast truths at once. As the echoes of their arguments faded, the stage was set for the twin lenses of a fractured glass to finally be aligned by a new kind of observer. Letting this knowledge settle into the quiet corners of the mind, we find ourselves standing upon the summit of Mount Wilson in the cool, thin air of the early 1920s. The great debate had left the astronomical community in a state of suspended animation, a quiet tension between two equally plausible visions of reality. To break this deadlock, the universe required more than just logic or intuition. It required a physical extension of the human eye that could pierce the celestial haze. Edwin Hubble, a man of focused determination, turned his attention to the night sky not with a mere looking glass, but with the most formidable instrument of his era. The 100-inch Hooker telescope was the technological titan of its day, a massive eye of glass and steel that sat perched above the marine layer of Lowe's Angels. Its primary mirror, a thick disk of silvered glass, possessed a surface area capable of gathering light that had been traveling for millions of years, focusing it into a sharp, crystalline point. While previous observers had seen the spiral nebulae as mere smudges of luminescence, ethereal clouds that defied definition, the Hooker telescope offered a resolution that was transformative. It possessed the sheer optical strength to resolve the unresolved, to pull the individual grains of light out of the collective glow. Where others saw a monolithic fog, Hubble began to see the distinct, pinprick signatures of individual stars. Imagine walking through a thick autumn mist where every object is a softened shadow, and then suddenly being handed a device that allows you to see the individual veins on a leaf a mile away. The Hooker telescope was a precision chisel for the light, carving away the ambiguity of the heavens. It was a deep-sea lantern capable of illuminating the individual scales on a creature swimming in the darkest trench of the void. This instrument acted as a bridge between the known and the unknowable, a massive crystalline funnel that drank the ancient rain of photons and poured them into the waiting vessel of human understanding. It was the master key that finally turned in the lock of the Andromeda Nebula, revealing that the gas was not gas at all, but a vast, shimmering congregation of suns. It was a precision sieve for the stars, sifting the cosmic dust until only the pure gold of individual stellar bodies remained. Through this lens, the blurry periphery of our knowledge began to sharpen into a distinct and terrifyingly beautiful reality. The telescope was not merely a tool, but an optical harbor where the faint, traveling light of the deep past could finally come to rest and be recognized. Drifting deeper into the silvered grain of those historic glass plates, we find ourselves standing beside Edwin Hubble in the cold, quiet air of 1923. He was meticulously scanning the outskirts of the Andromeda Nebula, looking for the sudden, violent flares of novae, those transient outbursts that signal a star's temporary surge in brightness. On one particular photographic negative, he spotted a tiny, unassuming speck of light. With the practiced hand of a cosmic cartographer, he initially inked the letter N beside it, cataloging what he believed was just another fleeting explosion in a distant cloud. But as he compared this plate to others taken on different nights, the speck did not fade away into the darkness as a nova should. Instead, it behaved with a strange, rhythmic persistence. It dimmed and brightened, then dimmed again, following a predictable and steady cycle. This was no chaotic eruption. It was a rhythmic pulse of a deep-sea current. With the stroke of a pen, Hubble crossed out the N and wrote VAR in bold, triumphant letters, followed by an exclamation point that still echoes through the halls of astronomy. He had found a Cepheid variable star nestled within the spiral arms of M 31. This specific class of star was already known to be a reliable indicator of distance, a luminous inhalation of a distant giant that could finally measure the gap between us and that shimmering smudge of light. By identifying this single, pulsing sun, Hubble transformed the nebula from a nearby cloud of gas into a separate, vast entity. The Cepheid was the first clear signal broadcast from across the intergalactic void, a rhythmic pendulum of the void that proved Andromeda was not a tenant of our own Milky Way, but a peer, a sister galaxy located millions of light years away. It was as if a solitary glint of a cosmic glowworm had been spotted in a storm, its consistent blink revealing the true scale of the meadow. This point of light acted as a golden thread of periodicity, sewing together the local neighborhood with the far-flung reaches of the universe. In that moment, the cosmos expanded. The walls of our celestial home fell away, replaced by an open sea where galaxies drifted like majestic, sovereign armadas of light. The identification of this Cepheid was the definitive crack in the shell of the old universe, allowing the light of a much larger reality to pour in. It was the rhythmic drumbeat of a cosmic heart, beating in time with laws we were only just beginning to grasp. A singular rhythmic feather drifting on the winds of time that anchored our understanding of the infinite. Letting this knowledge settle, we find ourselves standing upon the shoulders of those who looked at the sky not just with wonder, but with a meticulous, rhythmic patience. Before Hubble could bridge the gap to the Great Spiral, a quiet revolution had taken place in the glass plates of the Harvard College Observatory. Henrietta Swan Leavitt, working with the silent diligence of a librarian of the flickering dark, had uncovered a secret hidden in the variable pulses of the Cepheids. She realized that these stars were not merely flickering at random. They were governed by a strict internal law. The duration of their pulse, the time it took for the star to swell and contract, brightening and dimming, was a direct reflection of its true intrinsic power. A longer, slower rhythm belonged to a star of immense wattage, while a rapid, frantic pulse signaled a more modest light. This was the Rosetta Stone of the heavens, a way to translate the language of time into the language of distance. Hubble took this profound correlation, this Leavitt's law, and applied it to the solitary pulse he had found within the Andromeda Nebula. By measuring the precise interval between the star's peaks of brightness, he was able to determine its absolute luminosity, the true fire burning at its core, independent of how far away it might be. It was as if he had discovered a celestial tuning fork, one whose pitch revealed its size and strength. With the true wattage in hand, the rest was a matter of cosmic geometry. He compared this intrinsic brilliance to the faint, ghostly shimmer that reached his telescope. Like a traveler gauging the distance of a campfire by the softness of its glow, he knew that light fades in a predictable, mathematical sequence, weakening with the square of the distance it travels. This inverse square relationship meant that for every doubling of the void, the light grew 4 times more fragile, thinning out like a fine silk stretched across the dark. The gap between the star's true self and its apparent ghost was the key that unlocked the door to the void. This calculation transformed the Cepheid from a mere point of light into a cosmic yardstick of staggering precision. It was no longer just a star. It was a calibrated signal, a rhythmic bell tolling across a canyon so wide it defied human intuition. Hubble was using the star's own heartbeat to measure the length of the bridge between our home and the unknown. In this moment, the universe ceased to be a flat tapestry and became a cavernous, three-dimensional reality, stretching out in every direction like a vast, dark ocean where the only landmarks were these pulsing hearts of fire. The law of the Cepheid provided the steady hand needed to draw the map of the infinite, turning the terrifying silence of the deep into a measured, navigable expanse of the deep. Letting this knowledge settle, we find ourselves standing at the very edge of a map that has suddenly begun to grow, stretching far beyond the familiar contours of our local sky. Hubble's work with the Cepheid variables in the Andromeda Nebula was more than a mathematical exercise. It was the final blow to the idea of a provincial cosmos. By applying the period luminosity relation to that single, pulsing star, he could finally calculate the gap between our own stellar neighbors and that mysterious, spiraling smudge in the constellation of the Princess. The result was a number that defied the established geography of the era. He estimated the distance to be nearly 1 million light-years, a figure that, while smaller than our modern measurement of 2.5 million, was nonetheless a revolutionary departure from the accepted scale of the heavens. To understand the magnitude of this discovery, one must look at the prevailing model of the time. Harlow Shapley had constructed a majestic vision of the Milky Way, a sprawling expanse of stars 300,000 light-years wide. It was a gargantuan structure, and to many, it seemed impossible that anything could exist outside its borders. But Hubble's calculation placed Andromeda over 3 times further away than the very edge of Shapley's universe. This was not a minor adjustment. It was an eviction of the nebula from our own galactic home. It proved that the light reaching the mountaintop observatory had traveled through a vacuum so immense that it rendered the Milky Way a mere component of a much larger reality. The revelation was like a traveler who had spent his entire life believing the forest ended at the horizon, only to find the light of a remote bastion of light rising through the mist of an unmapped wilderness between the stars. It was the discovery that our celestial home was not a solitary dwelling in a void, but merely one outpost of an alien sun in a sprawling, silent landscape of giants. Andromeda was no longer a wisp of gas caught in our local winds. It was a luminous stronghold of gravity, a mirror image of our own majesty hanging in the deep. This calculation acted as the limit of the ancestral map, marking the point where the familiar ended and the truly infinite began. We were no longer the masters of a single, all-encompassing kingdom, but inhabitants of one autonomous domain among many, looking out across the great divide of the vacuum toward a distant signal fire on a dark horizon. This vast clearing in the cosmic woods revealed that the threshold of the known world was merely the beginning of the journey. Letting this knowledge settle, we observe the total reorganization of the human map, a moment where the architecture of existence was fundamentally redrawn. For centuries, the sky was perceived as a singular, cohesive entity, a grand and solitary mechanism where every visible light was a gear within the same clockwork. This new data, however, acted as a silent earthquake, shaking the foundations of that unified structure until it fractured into a countless multitude of independent worlds. The universe was no longer a single, dense continent of stars. It had become a vast, scattered collection of sovereign provinces, where each galaxy was a separate landmass, separated by a sea of silence, so immense that the light itself grew weary during the crossing. This shift represented the ultimate decentralization of our reality. We moved from living in a walled garden to standing on the shore of a limitless ocean, looking out at the distant silhouettes of other continents that had always been there, hidden in the haze of our own proximity. Technically, this discovery redefined the vacuum. The space between the stars within our own Milky Way was now understood to be a mere courtyard compared to the staggering emptiness that lay between the galaxies. These intergalactic voids were revealed as the true dominant feature of the cosmos' vast, lightless territories that separated the concentrations of matter like deep canyons dividing mountain ranges. The universe was not a solid object, but a sparse web, a delicate lace where the threads were millions of light years long, and the nodes were entire civilizations of suns. It was a transition from a closed system letting this knowledge settle, we find ourselves standing at the edge of a new order, where the chaotic distribution of light begins to reveal a hidden symmetry. In 1926, as the echoes of the Great Debate were still resonating through the halls of science, Edwin Hubble sought to bring a sense of taxonomy to the infinite. He looked upon the thousands of distant smudge-like forms and realized they were not random accidents of nature, but followed a distinct morphological progression. This realization birthed his morphological classification scheme, a visual lineage that organized the heavens by their outward appearance. This arrangement, which we now visualize as a bifurcated path of form, provided the first structural grammar for the language of the stars. It was an attempt to find the underlying geometric logic that gravity follows when it gathers billions of suns into a single, cohesive entity. At the base of this structural path lie the ellipticals, smooth and featureless, ranging from perfect spheres to elongated ovals. As we move along the handle of this progression, we reach a critical junction, a transitional state known as the lenticular galaxy. From here, the path splits into two distinct branches of complexity. One branch holds the normal spirals, where luminous arms wrap tightly or loosely around a glowing core. The other branch reveals the barred spirals, unique for the straight line of stars and gas that pierces their centers like a structural beam before giving way to the graceful curl of the outer arms. Hubble's scheme was more than a catalog. It was a recognition that the universe has a finite number of ways to arrange its majesty, a set of recurring themes in the silence of the void. Think of a quiet wanderer on a vast, twilight shoreline, gathering the various treasures washed up by the tide. Each galaxy is like a shell, some polished smooth by the relentless currents of time, others possessing intricate ridges and delicate, spiraling chambers that whisper of the forces that shaped them. Hubble was the first to realize that these shells could be sorted into families, that the variety of the cosmos was not infinite, but followed a deep, structural rhythm. This classification is a botanical guide to the celestial garden, a way to recognize the different species of light that inhabit the dark. It is a magnifying glass for the mind, allowing us to look at a distant glimmer and understand its internal structure, its history, and its place in the grand hierarchy of the void. We are no longer lost in a blizzard of light. We are now students of a grand, geometric architecture, reading the signatures of gravity written across the face of the deep. Letting this knowledge settle into the stillness of the mind, we find ourselves standing before the most serene inhabitants of the deep, the elliptical galaxies. Unlike the frantic, star-forming spirals, these are the elders of the cosmos, smooth and featureless spheroids that hold their secrets in a soft, golden haze. Hubble looked upon these monolithic structures and realized they could be measured by their silhouette alone, their geometry, a quiet indicator of their internal poise. He devised a system as elegant as the shapes themselves, labeling them with the letter E, followed by a number from 0 to 7. This numerical suffix is a precise mathematical shorthand for their degree of flattening, calculated by comparing their longest and shortest axes. An E0 galaxy is a perfect sphere of stars, a celestial ball of light that appears identical from every angle of observation, possessing a symmetry that feels almost divine. As the number increases, the sphere begins to yield to the pressure of its own history, stretching and elongating. By the time we reach the E7 classification, the galaxy has become a thin, cigar-shaped spindle of light, pulled taut by the invisible hands of rotation and gravitational interaction. These are not merely shapes. They are the physical manifestations of the kinetic energy stored within trillions of ancient suns, each classification a snapshot of a different equilibrium. Imagine these galaxies as stones gathered from the shore of an infinite ocean, each one tumbled and smoothed by the currents of eons. The E0s are the perfect marbles, rounded by a history of uniform motion, while the E7s are the flattened river stones, shaped by a more directed flow. They are like glowing eggs of varying proportions, resting in the velvet nest of the vacuum. This classification is a taxonomy of stillness, a way to map the quietest corners of the universe, where the chaos of gas and dust has long since been spent. We are observing the final, polished forms of matter, the elegant end states where gravity has finished its primary work and left behind a collection of luminous sculptures. Each number on Hubble's scale is a note in a low, resonant chord, a measure of how much a sphere of light has been pressed by the weight of time into a new and elongated grace. They stand as monuments to a long ago turbulence that has finally found its rest. A gallery of geometric perfection suspended in the dark. Drifting deeper into the logic of these forms, we encounter a subtle ripple in our historical understanding, a moment where the map was mistaken for the journey. When Edwin Hubble first laid out his elegant tuning fork diagram, he saw more than just a classification. He saw a progression. To the eyes of the early 20th century, it seemed only natural that the smooth, featureless spheres of the E0 ellipticals were the cosmic infants, the primal seeds from which the complex, rotating spirals would eventually bloom. He hypothesized a linear path of maturation, where the simple, concentrated energy of an elliptical galaxy would gradually flatten and unfurl, spinning out the intricate arms of a spiral like a blossoming flower. It was a beautiful, intuitive vision of a universe growing in complexity, a narrative of celestial adolescence leading to the grand maturity of the Milky Way and its kin. This was the era of the evolutionary hypothesis, a belief that the universe moved from the simple to the complex in a straight, unwavering line. Yet, as our instruments sharpened and our understanding of stellar populations deepened, we realized that the sequence tells a very different story. The ellipticals are not the beginning, but often the end. They are the seasoned veterans of the void, systems that have already burned through their youthful exuberance. While a spiral galaxy is a vibrant, chaotic workshop filled with the raw materials of gas and dust, an elliptical is a finished manuscript, its pages bound, and its story largely written. These massive collections of stars are characterized by their lack of the cold, dense gas required to kindle new suns. They are composed of ancient, red stars, the long-lived survivors of a distant era. Instead of being the precursors to the spirals, many ellipticals are the result of grand mergers, the final punctuation mark of gravity, where two or more galaxies have collided and settled into a stable, spherical equilibrium. They are the graveyards of motion, where the kinetic energy of billions of stars has been redistributed into a random, swarming heat. In this light, the Hubble sequence is less a timeline of growth and more a census of states. The ellipticals are like the polished gemstones of the vacuum, rounded and smoothed by the immense pressures of time and interaction. They represent a state of cosmic retirement, where the frantic pace of star formation has given way to a quiet, enduring glow. They are the weathered granite of the sky, standing firm long after the softer, more volatile structures have been reshaped. To look at an elliptical is to witness a silent library of ancient history, a place where every star is a record of a past collision or a long-faded burst of creation. We are no longer looking at a seed, but at a majestic, enduring monument, a testament to the fact that in the deep time of the universe, simplicity is often the ultimate complexity, the calm that follows the storm of creation. They are the echoes of a violent past that has finally found its silence. Letting this knowledge settle, we find ourselves at a peculiar crossroads in the grand architecture of the heavens. Between the heavy stillness of the ellipticals and the vibrant, winding motion of the spirals lies a transitional form, the lenticular galaxy. Astronomers often refer to these as S0 galaxies, placing them precisely at the pivot point of the cosmic taxonomy. They are the bridge between two worlds, a structural middle ground that reveals the subtle gradations of galactic life. In the early 20th century, as the map of the universe was being drawn, these objects appeared as anomalies, possessing the flattened shape of a disk, yet cloaked in the monochromatic glow of an ancient population. They represent a state of limbo, a moment where the universe seems to hesitate before committing to a specific design. From a structural perspective, a lenticular galaxy is a study in restrained geometry. It possesses a well-defined central bulge, a dense sphere of stars that serves as its gravitational heart, surrounded by a thin, circular disk. However, the defining feature of the lenticular is what it lacks. There are no sweeping spiral arms, no lanes of dark dust carving through the light, and no brilliant nebulae where new suns are being born. The gas reservoirs that fuel the fires of creation have been depleted or perhaps swept away by the intense pressures of a galactic cluster. What remains is a disk of aging stars, orbiting in a disciplined, quiet harmony. They are often quenched systems, where the frantic activity of youth has transitioned into a steady, unchanging middle age, their star formation long since silenced by the loss of their interstellar breath. To envision a lenticular galaxy is to see a spinning glass plate caught in the amber of time. It is a cosmic lens, polished by the ages, focusing the light of a billion old suns into a single, soft glow. Imagine a grand ballroom where the music has finally stopped. The dancers remain on the floor, still moving in their circular patterns, but the energy of the performance has softened into a rhythmic, predictable glide. They are the faded etchings of an oncidynamic system, a blueprint of a spiral that has lost its ink. If the elliptical is a solid stone and the spiral is a rushing stream, the lenticular is the thin sheet of ice that forms upon the water's surface, retaining the shape of the liquid beneath, but frozen into a state of permanent, shimmering clarity. They are the quiet sentinels of the transition, reminding us that form can persist even after the creative fire has moved on, standing as the ghosts of motion in a theater of light, drifting deeper into the architecture of the void. We find that the quiet, frozen forms of the lenticular give way to a more intricate bifurcation of design. When the first surveyors of the deep night looked upon these revolving burrows, they noticed a fundamental divergence in how the great arms of light emerged from their central sanctuaries. This observation led to the primary division of the spiral family, a split between the classic normal spirals and those that carry a distinct linear mark across their hearts. Letting this knowledge settle, we recognize the normal spirals, designated by the simple letter S, as the archetypal vortexes of brilliance in the heavens. In these systems, the spiral arms originate directly from the rounded glow of the galactic bulge, winding outward in a seamless, unbroken curve. They are the pure expressions of orbital resonance, where gravity pulls the stars into a continuous, liquid motion that seems to have no beginning and no end. But as our gaze sharpens, we encounter the barred spirals, the SB class, which represent nearly half of the spiral population. Here, the structure undergoes a dramatic transformation. Instead of arms emerging from a central point, a straight, stiffened ribbon of suns and gas cuts through the nucleus like a luminous girder of the galactic heart. This bar is a massive gravitational conduit, a radiant axle upon which the rest of the galaxy turns. It acts as a stellar conveyor belt, a powerful mechanism that exerts a torque on the surrounding gas, channeling the raw materials of creation toward the center with focused intensity. It is a startling revelation to find that our own Milky Way belongs to this sophisticated group, possessing a central bar that dictates the flow of its vast, swirling outlying provinces. Imagine the normal spiral as a floral arrangement of light, whose petals curve inward to a single, soft point of origin. In contrast, the barred spiral is like a majestic dragonfly of the deep, where a long, slender body of stars provides the structural axis from which the gossamer wings of the spiral arms extend. The bar is a shimmering causeway spanning the darkness of the core, a celestial highway that organizes the chaos of motion into a linear discipline before allowing it to break into the familiar curves of the spiral. It is a different kind of balance, a structural maturation where the galaxy has grown a specialized keel to better manage the immense energies of its own rotation, a luminous meridian that marks the path for billions of suns. The bar is not merely a visual feature, but a dynamic engine, a restless shaker of the stellar contents that prevents the galaxy from settling into a stagnant, circular sleep. Letting this knowledge settle into the quiet corners of the mind, we begin to notice that not all spirals carry their weight in the same fashion. Astronomers, in their patient observation, realized that the spiral is not a single rigid template, but a spectrum of morphological grace. They devised a subtle alphabet, using the lowercase letters of B and C to denote the specific posture and texture of these rotating empires. This classification is a delicate triage of light, based on 3 fundamental pillars of galactic anatomy that reveal the internal life of the system. The first criterion is the prominence of the central bulge relative to the surrounding disk. In the SAW galaxies, this core is a dominant, swollen orb of ancient stars, casting a broad, golden glow that occupies a significant portion of the total luminosity. As we move toward the SC types, this central heart shrinks, becoming a modest, compact seed buried within a much wider expanse of swirling material. It is as if the galaxy is shifting its focus from the concentrated wisdom of the center to the sprawling potential of the periphery. The second pillar is the tightness of the winding. The SAW galaxies possess arms that are wrapped with incredible discipline, like a bolt of fine silk wound closely around its spool, leaving little space between the luminous layers. These arms are smooth and continuous, suggesting a high degree of gravitational organization. By contrast, the SC galaxies unfurl their arms with a wilder abandon. They are loose and open, reaching out into the dark with a relaxed geometry that allows the void to breathe between the stellar currents. Finally, there is the texture of the arms themselves, a quality of clumpiness that marks the presence of new life. In the early 8-ups, the arms often appear as a smooth, milky haze, indicating a more mature population of stars and a quieter, more settled existence. But as we transition toward the C-types, the arms break apart into a series of bright knots and luminous clusters. These are the nurseries where giant blue suns are born in a frantic burst of energy. Here, the spiral is no longer a smooth ribbon, but a jagged, sparkling necklace of newborn light, vibrant and restless. This progression is like watching a tightly furled rosebud slowly opening its petals to the sun, or observing the transition from a calm, deep river current to the whitewater spray of a mountain stream. It is a visual record of how a galaxy balances its mass and its creative fire, a taxonomy of the different ways gravity can weave a tapestry of stars. In this quiet classification, we find a map of maturity, where every degree of winding and every variation in clumpiness tells a story of how much gas remains to be ignited, and how tightly the central heart holds onto its celestial children. Drifting deeper into this structural symphony, we find that the visual grace of the spiral is merely the surface of a much deeper physical reality. The classification of a galaxy from SAW to SC is not just a matter of geometry. It is a measurement of its very metabolic state. In the earlier types, the SAW galaxies, we witness a state of majestic composure. Their central bulges are immense, containing a vast population of ancient, amber-hued stars that have survived for billions of years. These galaxies have largely exhausted their reservoirs of cool hydrogen gas, leaving little material for the birth of new suns. Their spiral arms are wound with a disciplined tightness, like the coiled spring of a vintage timepiece that has been meticulously set. They act as the quiet archives of the universe, where the frenetic energy of youth has transitioned into a steady crimson glow. Moving along the sequence toward the SC types, the physical character undergoes a profound transformation. Here, the central bulge is diminutive, almost an afterthought compared to the sprawling, untamed arms that reach out into the void. These galaxies are drenched in gas and dust, the raw ingredients of creation that remain unspent. This abundance of fuel triggers a riot of star formation, casting a brilliant, electric blue light across the disk. This color is the signature of high-mass stars that burn hot and fast, living their entire lives in the blink of a cosmic eye, while the SAW galaxy is a vessel of preservation. The SC is a laboratory of innovation, constantly reinventing itself through the violent ignition of new light. We see a direct correlation between the tightness of the arms and the richness of the gas. The more loosely a galaxy holds its structure, the more actively it breathes. It is the difference between a seasoned, leather-bound volume whose story is fully written and a fresh ream of parchment, still wet with ink and waiting for the first lines of a new epic. In this transition, we observe the fundamental tension of the cosmos, the balance between the accumulated gravity of the past and the gaseous promise of the future. The Hubble sequence, then, is a ledger of cosmic spending, showing us which systems have hoarded their light and which are scattering it across the darkness in a magnificent blue-white spendthrift display. This physical correlation tells us that a galaxy's shape is its destiny, an outward manifestation of its internal chemistry, and the rate at which it converts its primordial inheritance into the currency of starlight. Drifting deeper into the nuances of these celestial shapes, we find that the elegant simplicity of the Hubble fork was merely the first layer of a much more intricate reality. In 1959, Gerard de Vaucouleurs recognized that the universe refused to be neatly pinned down into just 2 or 3 linear paths. He expanded our vision into a 3-dimensional classification volume, a conceptual space where the variety of galactic forms could breathe and expand. This was not just a list, but a topographical map of the heavens, accounting for the subtle gradations that Hubble had glimpsed but not fully codified. De Vaucouleurs looked closer at the transition points, the places where a barred galaxy begins to lose its rigidity, or where a smooth spiral develops a circular crown. He introduced a notation for the rings that often encircle the galactic nucleus, those delicate circlets of starlight that act as a secondary stabilizing force within the system. This system moved beyond the binary of barred or unbarred, introducing a spectrum of intermediate stages that recognized the messy, glorious complexity of cosmic evolution. It was a transition from a simple sketch to a full, sculpted relief of the mountain face of reality. In this refined view, we see the introduction of the inner ring, denoted by a small r, and the S-shaped spiral, denoted by a small s, creating a language that could describe the subtle curl of a galactic arm or the perfect enclosure of a stellar halo. This was the moment the cosmic atlas gained its depth, acknowledging that a galaxy is not a static icon, but a dynamic, evolving structure with layers of history written in its geometry. Imagine a master jeweler examining a collection of pearls, realizing that their beauty lies not just in their roundness, but in the unique luster and the microscopic ridges that tell the story of their growth. This classification volume is the jeweler's loop for the cosmos, a tool that allows us to see the fine-grained details of the stellar medium. It is like moving from a world of flat shadows into a room filled with light and shadow, where every angle reveals a new facet of the geometric dialect of the vacuum. We are no longer just looking at shapes. We are reading the mathematical choreography of the deep, understanding how gravity can twist a bar into a ring or pull a smooth disk into a chaotic, beautiful swirl. De Vaucouleurs also integrated the concept of the stage, a measurement of how far a galaxy has progressed along its morphological journey, adding a temporal dimension to our visual understanding. It is a recognition that the universe is not made of finished objects, but of processes caught in a state of becoming. This three-dimensional model acts as a haven for the celestial vagabonds, the irregulars, and the transitional forms that previously lived in the margins of our maps. It transforms the lonely fork into a vibrant, luminous globe of potential, where every star system finds its coordinates in the vast, silent compendium of the light. Drifting deeper into the subtle architecture of the night, we find that the light often gathers in specific, rhythmic patterns that demand a more delicate vocabulary. De Vaucouleurs looked upon the face of the heavens and saw that the spiral arms were not always solitary threads. Sometimes they conspired to form perfect, luminous circles. He introduced the notation of the ring, a quiet R placed within the classification to denote an inner ring. This is a diadem of suns that sits comfortably within the galaxy's disk, often marking the boundary where a central bar's influence meets the wider reach of the arms. It is a sign of stability, a place where the gravitational currents have found a harmonious balance, allowing matter to pool like water in a high mountain basin. Conversely, he used the S to describe the pure spiral, the S shape where the arms break free with a sense of urgent, outward motion, unconstrained by circular enclosures. These are the wilder currents of the cosmos, flowing directly from the source into the dark. Between these two states lies the RS, the transitional form where the arms curve with the intent of forming a ring, creating a shape that suggests a closing loop while maintaining the open, flowing grace of the spiral. These notations are more than just labels. They are the signatures of dynamical resonances. They map the regions where the rotation of the galaxy and the motion of individual stars hum in unison, creating standing waves of light. It is as if the galaxy is a musical instrument, and these rings are the nodes where the vibration is most clear and sustained. We are observing the physical manifestation of harmony on a scale that defies the human breath. To look at an R-type galaxy is to see a halo of silver mist caught in a moment of eternal stillness, a wreath of suns that defines the inner sanctum of a stellar empire. The S-types are the nomadic currents, their paths etched in a continuous, unbroken line of creation. And the RS types are the hesitant dreamers, caught in the act of turning inward while still reaching for the distant horizon. This notation allows us to see the galaxy as a living, vibrating entity, governed by invisible fences of force that guide the stars into their decorative orbits. It is a recognition that even in the vast, cold vacuum, there is a preference for order, a tendency for the light to find its way into a perfect, glowing circle, reflecting the deep, resonant heart of the universe. This R notation captures the moment when the galaxy's internal tides reach a state of grace, carving out a circular path that the stars follow with a quiet, clockwork devotion. The bar, that central girder of light, acts as a stirring rod, pushing and pulling the gas and stars until they find these stable harbors of motion. In the presence of a strong bar, these rings become the dominant feature, a secondary heart beating within the larger body of the galaxy. The S notation, by contrast, is the mark of a galaxy in a more fluid, perhaps more primitive or energetic state, where the arms are free to wander the void like unanchored vines. It represents a lack of these closed resonances, a system where the flow is outward and ever-expanding. The mixed RS stage is the most poetic of all, a visual dialogue between the circle and the line, a galaxy that is deciding whether to embrace the enclosure of the ring or the freedom of the spiral. It is a snapshot of an evolutionary whisper, a transition caught in the amber of our observations. Through these letters, de Vaucouleurs gave us a way to read the stress and the harmony of the galactic disk, to see where the laws of orbital mechanics have laid down a track for the stars to follow. We are no longer looking at a blurry smudge of light, but at a finely tuned mechanism of resonance and rhythm, a masterwork of celestial engineering that operates on a timeline of eons. Letting this knowledge settle into the quiet corners of the mind, we begin to see that the order of the cosmos is not a rigid boundary, but a slow, dissolving gradient. De Vaucouleurs looked at the SC galaxies, those wide, open spirals, and realized that the fraying of the galactic form continued even further than the original maps suggested. He extended the alphabet of the heavens to include the S stage, where the central nucleus is no longer a dominant sun, but a mere grain of salt in a vast, sprawling sea of blue stars. These are galaxies that have almost forgotten their center, where the spiral arms are so loose and thin they resemble the trailing threads of a tattered silk ribbon drifting in a light breeze. In this realm, the gravity that once pulled everything into a tight, rhythmic dance has begun to relax its grip, allowing the stars to wander into more eccentric, lonely paths. From there, the classification drifts into the SM stage, named for the Magellanic clouds that hover near our own Milky Way. Here, the symmetry that once defined the spiral family begins to break apart entirely. It is a stage of one-armed giants and asymmetrical drifts, where the galaxy is neither a structured wheel nor a chaotic cloud, but a bridge between the two. The SM stage represents a moment where the collective motion of billions of suns is yielding to the local whims of turbulence and fresh, violent star birth. Finally, we reach the IM stage, the truly irregular masses. In these systems, the grand design has vanished. There is no central throne, no winding causeway, and no geometric law. Instead, there is a vibrant, messy vitality. These are the wild thickets of the universe, where gas and dust ignite in spontaneous bursts of creation, untethered by the heavy hand of a massive core. This extension transformed the sequence from a collection of distinct shapes into a living continuum of form. It showed us that a galaxy is not a static object, but a delicate balance between the pull of the center and the energy of the periphery. If an elliptical is a polished stone and a spiral is a blooming flower, these irregular systems are the scattered petals caught in a summer breeze. They remind us that there is beauty in the broken and the asymmetrical, and that the universe is just as present in the chaotic flicker of a small, irregular cluster as it is in the majestic rotation of a grand design spiral. We are witnessing the slow surrender of geometry to the raw, unrefined pulse of the vacuum, a reminder that even in the deep silence, there is room for the unexpected and the beautifully unaligned. Drifting deeper into the nuances of form, we find that the human mind often seeks to divide the world into opposites, the presence or the absence of a thing. In the early days of mapping the heavens, a galaxy was either possessed of a central bar or it was not. But as Gerard de Vaucouleurs looked closer at these islands of light, he realized that nature rarely speaks in such absolute terms. He saw that the bar was not a simple switch, toggled on or off by the mechanics of gravity, but a presence that waxes and wanes across a vast spectrum of intensity. He introduced the classification of SAB, a middle ground that acknowledges the subtle, the transitional, and the partially formed. This intermediate designation represents a galaxy where the linear concentration of stars is present, but perhaps less dominant, a suggestion of a bar rather than a command. In a strongly barred system, the gravitational potential is stretched into a powerful, elongated oval that dictates the motion of every star and gas cloud within its reach. In an unbarred spiral, the potential remains nearly circular. The SAB classification captures that delicate moment where the circular symmetry begins to fail, where the orbits of stars start to elongate and lean into a common direction without fully surrendering to a rigid central beam. It is a measurement of bar strength, a recognition that the force of the bar can be a faint tremor or a resounding pulse, influencing the way gas is funneled toward the center and how the spiral arms are anchored to the core. Imagine a river whose flow is being gently guided by a submerged ridge. In some places, the ridge is sharp and high, forcing the water into a narrow, rushing channel. This is the strong bar, a definitive path for the celestial current. In others, the river flows wide and undisturbed, a perfect circular pool. But then there are those reaches where the ridge is just a soft rise on the riverbed, a subtle suggestion that causes the water to ripple and sway, leaning toward a new direction without losing its broad, expansive character. This is the SAB, a gentle persuasion of the starlight. It is like the difference between a tree trunk that stands perfectly straight and one that has been slowly, almost imperceptibly, bent by a prevailing wind. The bend is there, a memory of force, yet the tree remains a creature of the vertical world. We are looking at the fingerprints of a gravitational pressure that is still in the process of asserting itself, a soft-spoken dialogue between the chaos of the circle and the discipline of the line. It tells us that the universe is not made of rigid categories, but of thresholds and transitions, where one state of being quietly dissolves into the next, like the fading of a summer dusk into the deep velvet of night. Drifting deeper into the ledger of the heavens, we find that these descriptions are far more than mere aesthetic flourishes. They are the rigorous language of a cosmic inventory, a way to translate the silent, shimmering beauty of a galaxy into the hard currency of data. When we encounter notations in vast repositories like the NASA IPAC extragalactic database, we are witnessing the legacy of Gerard de Vaucouleurs, refined into a tool of immense quantitative utility. A code such as SABRSCD is not a poetic abstraction. It is a sophisticated shorthand that speaks of a galaxy's fundamental nature. In the modern era, these classifications serve as a cipher of the stars, unlocking the relationship between the way a galaxy looks and the physical laws that govern its heart. By categorizing the subtle transition from a bar to a ring, or the specific looseness of a spiral arm, astronomers can predict the underlying physics without ever needing to measure every individual star. This system operates as a grand index of physical parameters. The notations are deeply entwined with the gas fraction of a system, the primordial mist that has yet to be forged into suns. A galaxy marked with the later stages of the de Vaucouleurs sequence, the C and D types, is often a reservoir of untapped potential, rich in the cool, dark clouds of hydrogen that shimmer with the promise of new light. These are the fertile fields of the cosmos. Conversely, the earlier notations signal a more settled, perhaps more exhausted state, where the creative fires have begun to dim and the gas has been spent. The presence of an inner ring, denoted by that small, elegant RS, is a signature of gravitational resonance, a signpost indicating how matter has been herded by the rhythmic chorales of gravity. It is a remarkable feat of human observation that a visual taxonomy can so accurately mirror the invisible ratios of mass, momentum, and chemistry. Think of this system as a botanist's inventory, where the specific curve of a petal or the texture of a bark is not just a description of beauty, but a precise indicator of the soil's mineral wealth and the age of the hidden roots. It is a navigational chart for a sea of light, where the shape of the waves tells the sailor exactly how deep the water runs and what currents move beneath the surface. We are no longer just watching the stars. We are reading the blueprints of their construction. Each letter and parenthesis is a structural beam in the architecture of understanding, a way to organize the infinite variety of the night into a coherent story of matter and motion. It is the numerical spine of our cosmic curiosity, ensuring that every glow in the dark is not just seen, but deeply and mathematically known. In this way, the classification becomes an umbilical cord of logic, carrying our minds from the subjective wonder of a glowing shape to the objective reality of a universe built on law and order. Letting this knowledge settle into the foundation of our vision, we turn our gaze toward the very heart of the spiral structure, where the flatness of the disk gives way to a more profound and three-dimensional presence. As we move inward from the sprawling, thin plains of the galactic outskirts, the geometry of the galaxy begins to shift. It is no longer a simple plane of rotation, a thin sheet of starlight caught in a breeze. Instead, we encounter the central bulge, a massive spheroidal concentration of stars that rises like a gentle golden dome from the level landscape of the surrounding arms. This is the gravitational anchor of the entire system, a dense urban core where the laws of motion are dictated by a concentrated press of suns. In the technical language of the heavens, the bulge is a distinct anatomical feature, extending vertically both above and below the galactic plane, while the disk is defined by its elegant flatness and its disciplined circular motion. The bulge is a three-dimensional volume, a globe of light that closely resembles a miniature elliptical galaxy nestled within the larger spiral. It is as if the universe, in its grand design, decided to house a smaller, more stoic system within the heart of the more dynamic and youthful spiral arms. This spheroidal density represents a fundamental transition in the very nature of space. Here, the orderly, flat orbits of the periphery give way to a more complex, chaotic swarm of movement, where stars move in diverse, tilted paths that fill the entire volume of the center. To visualize, this is to see a great rise in the middle of a vast, flooded marsh, where the water flows in circles around the base, but the center holds firm, a solid mound of ancient earth that breaks the surface and reaches toward the heights. It is the pit of a celestial fruit, a hard, dense kernel of history that provides the structural integrity for the sweet, swirling flesh of the outer reaches. This central swelling is a heavy, luminous pearl at the center of the galaxy's shell, a sanctuary of density that defies the thinness of the outer void. It is the radiant nucleus of a cosmic cell, the point where the centrifugal forces of the disk finally yield to the overwhelming, inward-pulling weight of the collective whole. Here, in this spheroidal heart, the galaxy finds its balance, a solid core of concentrated light around which the rest of the universe gracefully turns. Letting this knowledge settle into the quiet corners of the mind, we turn our gaze inward, toward the very heart of the spiral architecture, where the thin elegance of the disk gives way to something more substantial. For centuries, this central region appeared to our ancestors as nothing more than a blurred, overexposed glow, a singular and indivisible flame that defied the resolution of the earliest glass lenses. They saw the periphery, the delicate arms reaching out like fingers, but the center remained a mystery of light, a saturated core where individual identities were lost in a collective brilliance. It was only as we began to measure the depth of the heavens with the precision of modern instruments that we realized the galaxy does not merely spin as a flat sheet. It possesses a majestic, three-dimensional volume at its core, a protrusion that breaks the symmetry of the horizontal plane. This is the anatomy of the central bulge, a massive, spheroidal concentration of stars that rises like a gentle hill from the surrounding plains of the disk. It is a structural departure from the rest of the system, a place where the rules of motion shift from the orderly, laminar rotation of a cosmic wheel to the pressurized, multi-directional dance of a dense crowd. Technically, this bulge acts as a miniature elliptical galaxy, living inside a spiral shell, a spheroidal province where stars are packed with an intensity that dwarfs the lonely, suburban reaches of our own solar neighborhood. It extends vertically, pushing far above and below the galactic plane, creating a silhouette that resembles a celestial yoke held within the translucent white of the disk. This vertical extension is the signature of its power, a sign that gravity here is so concentrated that it pulls matter into a tight, spherical embrace rather than allowing it to sprawl outward into thin ribbons. It is the luminous citadel of the galaxy, a fortress of ancient suns that provides the gravitational anchor for everything that orbits beyond. Think of it as the swollen knot in the grain of spacetime, a point of density where the fabric of the universe has been gathered and tucked into a neat, rounded bundle. It is the glowing hearth of a great mansion, the place where the heat and light are most concentrated, radiating a sense of permanence and age. In this central hive, the stars do not follow the rhythmic lanes of the spiral arms. Instead, they move in swarms, their orbits tilted and eccentric, creating a buzzing cloud of light that maintains the bulge's rounded form against the pull of the vacuum. It is the beating heart of a mountain, the solid and unyielding foundation upon which the more fragile, gaseous layers of the galaxy are built. We are looking at the original settlement of the galactic empire, the ancient district from which the rest of the spiral expanded, a place where the architecture is dense, vertical, and steeped in the weight of eons. It is a sovereign sphere of light, a rounded sanctuary that holds the majority of the galaxy's mass in a compact, glowing volume, reminding us that even in the vastness of the void, there are places where the stars gather so closely they almost touch. Letting this knowledge settle, we find ourselves peering into the kinetic heart of the galaxy, where the very nature of movement undergoes a profound transformation. In the outer reaches of the disk, there is a certain geometric serenity, a vast, disciplined parade of light, where billions of stars follow nearly circular paths, locked in a synchronized orbit that keeps the galaxy flat and thin. This is the realm of orderly rotation, a celestial carousel where the outward centrifugal force acts as a perfect counterweight to gravity's inward yearning. But as we move inward toward the classical bulge, this elegant machinery begins to dissolve into something far more primal and energetic. Here, the rules of the road are abandoned in favor of a magnificent, multidimensional chaos. The classical bulge is not held aloft by a simple spin, but by velocity dispersion, a frantic, random agitation of stars moving in every possible direction. It is a pressure-supported system where the sheer diversity of orbits creates a structural resilience that a mere rotation could never provide. Historically, astronomers viewed these regions as simple, glowing orbs, but modern physics reveals them to be dynamic arenas of high-energy interactions. If the disk is a liquid procession flowing in a singular, predictable direction, then the bulge is the vertical spray of a mountain waterfall, where every droplet is a sun leaping and diving through the void. In this central province, the stars do not march, they dart like sparks thrown from a blacksmith's anvil, their paths tilted and eccentric, weaving a dense, spherical armor of kinetic energy around the galactic core. This random motion acts as a thermal cushion, a self-sustaining storm of light that pushes back against the crushing weight of the center, maintaining that iconic, swollen silhouette. It is a kinetic vapor of suns, a restless assembly of random paths, where the lack of order is the very thing that provides stability, ensuring that the heart of the galaxy remains a tall, proud monument of light. Unlike the disk, which relies on the momentum of its birth to maintain its shape, the bulge is a manifestation of pure, unbridled energy, an arena of motion where the entropy of the stars themselves becomes the kinetic framework of the central glow. Letting this knowledge settle into the stillness of the mind, we begin to notice that not every heart beats with the same chaotic intensity. For decades, the central bulge was viewed as a singular, monolithic entity, a fossilized relic of a violent past. It was assumed that every galaxy's core was a classical bulge, born from the thunderous collision of smaller systems, where the kinetic shock of merging gas and stars forged a spherical swell of ancient light. But as our instruments grew sharper, capturing the subtle gradients of light and the specific velocities of individual suns, a different architecture emerged from the shadows. We discovered that some centers are not spheres at all, but rather delicate, flattened structures that mirror the elegance of the surrounding disk. These are the pseudobulges, the quiet imitators of the galactic core, revealing a more patient side of cosmic history, unlike their classical counterparts, which are defined by random, three-dimensional orbits. Pseudobulges retain the memory of the disk's rotation. They are supported not by the pressure of random motion, but by the momentum of a spinning plane, appearing flatter and more compressed against the galactic equator. Within these regions, we find younger, bluer stars, clear evidence of a heart that is still actively dreaming. Their origin is not one of external violence or catastrophic merger, but of secular evolution. This is a slow and inward journey where internal instabilities, such as the graceful presence of a galactic bar, gently shepherd gas toward the center over billions of years. This gas settles and ignites, building a new heart from the inside out, layer by luminous layer. If the classical bulge is a mound of earth thrown together by a sudden landslide, a rugged pile of history, then the pseudobulge is a silt deposit at the mouth of a slow-moving river, formed grain by grain as the water's own rhythm dictates where the land shall rise. It is a domestic growth, a garden tended by the galaxy's own internal winds, rather than a monument built by an invading force. It is the difference between a sculpture carved from a single block of stone and a vessel formed on a potter's wheel, where the motion of the spin itself creates the shape. In these pseudobulges, we see the galaxy as a self-sustaining organism, refining its own form through the quiet persistence of gravity, proving that even the most complex structures can arise from the steady, rhythmic flow of time. Drifting deeper into the structural heart of the galaxy, we move away from the dense, spherical core and enter the expansive, flattened realm known as the disk. Historically, the discovery of this structure was a slow awakening to our own perspective, as we realized that the pale band of light stretching across our night sky was the edge-on view of our own home. Astronomers came to understand that the disk is the physical manifestation of a great cosmic compromise between the inward pull of gravity and the outward momentum of rotation. It is the final form of a cloud that has found its balance, a geometric resolution to the turbulence of the early universe, much like a baker spinning a ball of dough into a wide, thin crust. This geometric transformation is the fundamental act of galactic creation, turning a chaotic volume of gas into a disciplined, rotating stage for the drama of the stars. The disk acts as the galaxy's metabolic center, containing the vast majority of its visible mass and the preponderance of its interstellar medium. Within this thin, rotating layer, the density of gas is high enough to facilitate the cooling required for gravity to take hold and birth new stars. This is the site of the most vigorous star formation, where the blue-white light of massive, short-lived suns illuminates the surrounding dust. The disk's rotation is nearly uniform in its circularity, a grand, orbital ballet that keeps the galaxy's fuel from being consumed all at once, spreading the gift of starlight across a wide, accessible plain. It is the engine room of the galaxy, a reservoir of cold gas that serves as the raw material for every sun that has ever warmed a planet's surface. Imagine the disk as a shimmering tidal flat at the edge of the universe, where the receding waters of the primordial past have left behind the fertile silt of hydrogen and helium. It is a spinning record of light, where the grooves are defined by the density waves of the spiral arms, and the music is the collective hum of 100 billion burning hearts. We might see it as an iridescent film of oil on a dark puddle, reflecting the hidden colors of the vacuum in a thin, fragile layer, or a circular loom of the heavens, where the threads of gravity are woven into the fabric of starlight. In this thin, vibrant slice of space, the galaxy remains forever young, a shimmering meadow of fire and ice where the cold breath of the vacuum meets the heat of new creation. It is the plane upon which the history of the future is written, a luminous horizon that defines the boundary between the emptiness of the void and the crowded, brilliant reality of a living galaxy. Letting this knowledge settle into the quiet corners of the mind, we begin to perceive that this galactic disk is not a monolithic slab of light, but a nuanced layering of time and motion. Early observers once saw only a single, shimmering plane, a uniform sheet of stars stretching into the dark. Yet, as our gaze sharpened, we discovered that the disk possesses a complex vertical anatomy, a tiered structure that reveals the sequential history of the galaxy's growth. It is a dual architecture, where the stars are sorted not just by their distance from the center, but by their height above and below the midplane, creating a stratigraphic diary of the Milky Way's turbulent youth and its more settled, mature present. At the heart of this structure lies the thin disk, a razor-sharp region of intense activity and modern creation, extending only about 300 to 400 parsecs in height. It is the primary nursery of the galaxy, home to the gas, the dust, and the luminous population, stars, that define the spiral arms. This region is described as dynamically cold, a term that belies its vibrant nature. In the language of astrophysics, cold refers to the order and discipline of its motion. These stars move in nearly perfect, circular orbits, like a calm river flowing without ripples. They are the young, metal-rich inhabitants of the current age, clinging to the central plane where the fuel for new suns is most concentrated. But surrounding this delicate layer is the thick disk, a more expansive and ancient province. This thicker component is a remnant of a more violent era, perhaps puffed up by ancient galactic collisions or the chaotic scattering of stars over billions of years. Its inhabitants are older, metal-poor travelers on more eccentric, hot orbits, rising high above the plane and plunging back through it, creating a ghostly, atmospheric envelope around the younger core. Imagine a tranquil lake on a windless morning, where a fine, dense layer of mist clings perfectly to the surface of the water. This mist is the thin disk, a precise and fragile veil where the moisture of creation is most potent, moving in silent unison with the currents below. It is a razor-thin sanctuary of order, a translucent film of potential. Above and below this mist, however, is a much larger, more diffuse haze, the thick disk. This outer layer is like the memory of a storm that passed long ago, a cloud of starlight that has been tossed upward by the winds of time, its particles moving with a restless, thermal energy that the calm mist has not yet known. It is the difference between the sharp, ink-dark lines of a new blueprint and the soft, faded charcoal of a sketch made centuries before. The thin disk is the living, breathing skin of the galaxy, while the thick disk is the deeper, weathered muscle, holding the scars of every gravitational encounter the Milky Way has ever endured. In this vertical dance, the galaxy reveals its age, stacking the quiet, orderly present atop the chaotic, expansive foundations of its past.